Okay, so this is the supplementary test for 2021. Let's go through the questions. So we are given the points P, Q, R, and S. Now, first thing is we have to write QS in I, J, and K notation. So remember that QS, this is a displacement vector. So it's a displacement vector because the starting point is not the origin. So it's not O something. Position vectors, those start from the origin. So they're OA, OB, and so on. So the starting point is the origin. And every displacement vector can be written as a sum of position vectors. So QS, this is minus OQ plus OS, right? And this is minus OQ. We just take the coordinates of Q. This is 2, 0, minus 1. And then OS, this is P, 2, minus 1. So this is minus 2 plus P. So this is P minus 2. And then we have 0 plus 2. Negative 1 is 1 plus minus 1, that is 0. Okay, so now writing QS in I, J, and K notation, this is P minus 2. This is I. So you have to put the hat or underline it and not just write it as a normal I because it is a vector. Then we have plus 2J. And then 0K, so we don't even need to write it. And then it says, hence find the value of P such that the magnitude of QS is 2. So we work out the magnitude and equate it to 2 and then solve for P. So the magnitude of QS, this is the square root of the I coordinate squared plus the J coordinate squared. The K coordinate is 0, so we don't even need to write it. This is equal to 2. To get rid of the square root, we square both sides. P minus 2 squared plus 4. This is equal to 4. So this means P minus 2 squared is equal to 0. This means that P minus 2 is 0. And this means that P is equal to 2. Then this was 1.1.1. Then 1.1.2, it says if the angle PQR is 90 degrees, find the value of M. Okay, so what we need to do is we know that if we were to represent this, we have Q, we have P here, we have R. So this is what the vectors look like. Okay, so something like that. So what we need to do, because this angle here is 90 degrees, is just show that or use the fact that QP dot with PR is equal to 0. And then we can use that to solve for M. Okay, so we need to work out the position vectors. QP and PQ and PR, or PQ and RP. The order you put them in doesn't really matter. So whether this vector is going that way or going that way, the dot product is still 0 because they remain perpendicular. Okay, so we work out QP. This is minus OQ plus OP. This is minus OQ, sorry. This is 2, 0, minus 1. And then OP. This is 1, minus 2, and 4. So when we add these two together, we have negative 2 plus 1, it's negative 1, 0 plus negative 2, and then 1 plus 4, this is 5. that is QP. And then we have to find PR. PR is minus OP plus OR. So this is minus OP, this is 1 minus 2, 4, and then OR, 0 and 1. Okay, so this is minus 1 plus 0 is minus 1, 2 plus M, and then minus 4 plus 1 is minus 3. Okay, so the dot product of QP and PR is 0. So this means that minus 1, minus 2, 5, dot, minus 1, 2 plus M, minus 3 is equal to 0. So remember, this must be a dot. Using the times symbol means something completely different. Okay, so in vectors, when you put the X, the times, it doesn't mean the same thing as when you put the dot. So you have to be careful with the symbols you use. Okay, so this is equal to minus 1 times minus 1 plus minus 2 times 2 plus M plus 5 times minus 3. This is equal to 0. So we have 1 minus 4 minus 2M minus 15. This is equal to 0. So 1 minus 4 is minus 3. Minus 3 minus 15 is minus 18. So we have 2M is equal to minus 18. M is equal to minus 9. If the matrix 5x, 5, 1, 2 has no inverse, determine the value of x. So here we just need to remember that a matrix is singular, or it has no inverse, if the determinant of the matrix, I'm going to call it A, is equal to 0, then it is singular. So in the test, if you see the word singular in reference to a matrix, you should know that means it has no inverse. So you work out the determinant, equate to 0, and then solve for x. So we know how to work out the determinant of 5x, 5, 1, 2. Notice here that I'm not using the square brackets anymore. It's straight lines. That means determinant. So you have to be careful with the symbols that you're using because they mean different things. Okay, so this is equal to 5x times 2 minus 1 times 5. And because it's singular, this is equal to 0. So we have 10x minus 5 is equal to 0. 10x is equal to 5. And this means that x is equal to half. So when x is equal to half, this matrix has no inverse. Triangle KLM has the vertices as given below. The point N is the foot of the perpendicular from K to M. Okay, so we have a triangle that looks like this, something like this. So this is K minus 2, 1, L, this is 1, 7, and M, 3, 1. Now we're told that there is a perpendicular that goes from K to this line. So we draw a line like that, and it's perpendicular, so it meets the 90 degrees, and this point here is N. Now it's not in the middle, it may be, you don't know that, so you don't just assume that it is exactly halfway through. Okay, so we don't know anything about it. All we know is that there's a line from K to the line LM, and it meets at 90 degrees, and the point it meets at is called N. Then 1.3.1, we have to determine the gradient of the line LM. So the gradient of LM, this is just delta y over delta x. So we say 7 minus 1 over 1 minus 3. Okay, so this is 6 over negative 2, which is negative 3. Then 1.3.2, find the equation of the line Kn. So the gradient of Kn, this will be the negative reciprocal of Lm because they are perpendicular. So this will be 1 over 3, so that when I multiply this one and that one, the answer is negative 1. And then I have a point K on the line Kn, so I use the formula y minus y1 is equal to mx minus x1. So we have y minus 1 is equal to 1 over 3 x minus negative 2. So from there, we have y minus 1 is equal to 1 over 3x, and this will be plus because negative and negative, so plus 2 over 3. Okay, so leaving this in standard form, and when this goes that side, we have 5 over 3. Okay, then 1.3.3, it says, will the point 1,4 lie on the median of Km? Okay, the median of Km, you need to remember what is a median. Now, a median is a line from the opposite vertex to Km and passes through the midpoint of Km. So here, it's this line here. This is the midpoint of Km. So this is the midpoint. Okay, and it goes from the vertex L. Okay, so how do we check, does this point 1,4 lie on this median? We need to come up with the equation of the median, and then if this point satisfies the line, then it does lie on the line, otherwise it does not. Okay, so first thing is we need the midpoint of Km. So we take the 2 points of K and M, the x coordinate, we find the average, so it's minus 2 plus 3 over 2, and then 1 plus 1 over 2. This gives us a half and 1. Okay, so this is the midpoint here. It's a half and 1. Okay, now to find out if the point lies on the line, so again, you could find the equation of L and I shouldn't have called it M because there's already this line, this point M here. Let's say I called it T. Okay, just to differentiate it. So this point T over here. All right, so what you can do, there's 2 ways to do this actually. You can find the equation of LT and then substitute 1,4 into the equation, see if it satisfies. Or you can find the gradient of LT And then also the gradient of L and 1,4. If the two gradients are the same, then it lies on the line. Otherwise, it does not lie on the line, because to find out if 3 points are collinear, their gradients must be the same. Okay, so let's try using the gradients. So we're looking for the gradient of LT. This is just delta y over delta x. This is 7 minus 1 over 1 minus half. So this is 6 over a half, which is 12. Okay, and then you can work out the gradient of this point here. I'm going to call it S. Okay, so LS. Again, this is delta y over delta x. So I have 7 minus 4 over 1 minus 1. In fact, the gradient, I have 1 minus 1. This is undefined because I'm dividing by 0. And they're obviously not the same. This one is 12, this one is undefined. So we can say that since the gradients are not the same, then 1, 4 does not lie on the median. Okay, so that is one way to check and see if it lies on the median. The other way, like I said, is find the equation of the line LT. We already worked out the median. Finding the equation is not too difficult. Let's just quickly do it. So in a test, you don't need to do both of these methods. Just one of them is sufficient. So I have the gradient. My formula will be y minus y1 is equal to mx minus x1. So I have y minus 7. This is equal to 12x minus 1. So here I have y minus 7 is equal to 12x minus 12. So y is equal to 12x. When this one goes this side, I have minus 5. Then you substitute the 0.14 in there. Okay, so to substitute on the left-hand side, you have y is equal to 4. And then on the right-hand side, you have 12. Our x coordinate is 1 minus 5. So this is equal to 12 minus 5, which is 7. So we can see that the left-hand side is not equal to the right-hand side. Therefore, 1, 4 does not lie on the. Okay. So either of these two methods is sufficient. The choice is yours, which one you prefer to use. So if the question is specific, say use gradients, then you have to do it using the first way. Otherwise, pick the one that you are most comfortable with. Okay, so we are given that 3 sec theta plus 5 is equal to 0, and theta is a reflex angle. So that is important. What does reflex mean? Reflex means it's in the fourth quadrant. Okay, no, not necessarily in the fourth quadrant. It means it is greater than 180. So in the third or the fourth quadrant. Okay, find the value of 3 cosec theta minus cot theta without finding the value of theta. So these questions are important. The way you have to solve them is as follows. So first thing, with any trigonometric equation, make sine, cos, or tan the subject of the formula. So we have 3 sec theta plus 5 is equal to 0. So 3 sec theta is equal to minus 5. So this means that sec theta is equal to minus 5 over 3. Now sec is the reciprocal of cos. So I have 1 over cos theta is equal to minus 5 over 3. So this means that cos theta is equal to minus 3 over 5. That is the first thing. Now here, we can see that cos theta is negative, and cos is negative in the second or the third quadrant. But here we are told that theta is a reflex angle. That means it's greater than 180. So we need cos to be negative and for our angle to be greater than 180. So that can only be in the third quadrant. Okay, so it's important to read these questions correctly. That's how you come up with all of this. First, you make cos the subject of the formula. Next thing is you need to decide in which quadrant is my answer coming from. And that comes from the fact that our angle is reflex. Reflex means third quadrant, fourth quadrant. But we have that cos is negative, and cos is negative in the third quadrant. It's the only one that satisfies both these conditions. So we then draw our quadrants. So we then come up with a right angle triangle in the third quadrant. So we put theta over here. This is 90. Now we are told that cos of theta is negative 3 over 2. And we know that cos, this is the adjacent over the hypotenuse. Now the adjacent, this one here, this we will label it negative 3. The hypotenuse, this is 5. Okay, so when I divide the adjacent over the hypotenuse, I get negative 5 over 3. And then this side over here, I work it out using Pythagoras theorem. Okay, so I can call this one y because it's the y-axis. So we know that y squared, or just y, this is the square root of 5 squared minus negative 3 squared. This is the square root of 25 minus 9. This is the square root of 16. And this is 4. But if you look at my y-axis, it's negative. Okay, so this has to be negative 4 because this is in the negative y-axis. If it was up here, then it would be positive, but because it's below the x-axis, then it must be negative. Okay, so that's why it's important to, this step must be done correctly, and then you have to decide which quadrant it is in, so that you know that the value you get here is it going to be positive or negative. So here it is negative. Now you answer the question, what are we asked to find? 3 cosec theta minus cot theta. So 3 cosec theta minus cot theta. 3 cosec theta, this is 1 over sine theta minus, this is cos theta over sine theta. So we have 3 divided by, from my triangle sine theta, this is the opposite over the hypotenuse. So this is minus 4 over 5. And you can see it's negative. That's in the third quadrant. We should get a negative value. So there's no way that sine of an angle in the third quadrant would be positive. So if I had not drawn this correctly and then I just put 4 over here, I'd get positive 4 over 5. And that would mean I have the sine of an angle in the third quadrant being positive, and that's not possible. Okay, minus, and then cos of theta, you know, cos is the adjacent over the hypotenuse, minus 3 over 5, and then sine, this is minus 4 over 5. So this is 15 minus 15 over 4, and here negative, 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 give us negative. So 3 over 5 divided by 4 over 5 is 3 over 4. Okay. So this is minus 18 over 4, which is minus 9 over 2. Okay, and you could try it, work out theta, and then try and work out 3 cosec theta minus cot theta. You would still get this. But with these questions, it's very important that you do not find the value of theta. So if I see in the test that you have worked out the value of theta, you will not get any marks for this question. And 6 marks is a lot of marks to lose. Solve cot x, cos squared x is equal to a half cot x. So to solve this, the cot x cos squared x is equal to a half cot x. Okay, so with these trigonometric equations, don't divide everything by cot x and then it cancels out. You should rather factorize. So we have cot x given 2 cot x cos squared x minus cot x is equal to 0. Then you factor out cot x. So we have cot x is equal to 0, or 2 cos squared x minus 1 is 0. So here we have 1 over tan x is equal to 0. And that would mean 1 is equal to 0, which is not possible. Or it'd be better to rewrite it in terms of sine and cos, instead of saying it is not possible, because cot x can be negative, can be 0 actually. Okay, so my bad. So rather write this as cos x over sine x is 0. So this means that cos x is equal to 0, and then you'll get some solutions. Right, then with this one here, we have cos squared x is equal to a half. This means that cos x is equal to plus or minus 1 over the square root of 2. Remember, that is always our first step. You make sine, cos, or tan the subject of the formula. So with the first one, if cos x is equal to 0, cos x is equal to 0, this means that x is equal to 90. X is equal to 270. So when we have 0 here, our angle is one of the boundary angles. So either 0, 90, 180, 270, or 360. So these are the two values. Okay, and then the next one, we have cos x is equal to 1 over the square root of 2. So these two equations here, you must solve each of them. Alpha, this is cos inverse of 1 over the square root of 2, and this is 45. Then this is in the first and the fourth quadrant. So in the first quadrant, x is equal to 45 degrees. In the fourth quadrant, x is equal to 360 minus 45. This is 315 degrees. Then the other one, cos x is equal to minus 1 over the square root of 2. Alpha is cos inverse of half 1 over the square root of 2. You ignore the negative. It's 45 degrees. This is from the second and the third quadrant. In the second, x is equal to 180 minus 45, which is 135 degrees. In the third, x is equal to 180 plus 45, so x is 225 degrees. So those are your 6 angles that satisfy this equation. Metal component consists of a cylinder with a conical hole at its top. The depth of the conical hole is 8 centimeters, while the diameter of the hole is 6 centimeters. The cylinder is 20 centimeters high and has a base diameter of 16. If the component is melted, how many spheres of diameter 15 millimeters each can be produced from the molten metal, considering that 5% of the volume will be lost due to spilling? Okay, so draw a sketch. You have a cylinder like that. This cylinder has a hole, the shape of a cone, like that. So we are told that the cylinder is 20 centimeters high. Then the base diameter is 16. The depth of the cone is 8 centimeters, and the diameter is 6 centimeters. Okay, 5% of the volume will be lost due to spilling. So that means we have only 95% of the structure to make our spheres. So the spheres look like this, and the diameter of the spheres, what are we told? 15 millimeters. So keep in mind the units. So this is 1.5 centimeters. Okay. Yep. Anyway, so to find out the number of spheres, this is 95% of the volume of the cylinder minus the cone divided by the volume of the sphere. So this is basically how you would work it out. Okay, so now we substitute 95%, then 5, then we multiplied the volume of the cylinder. This is pi r1 squared times the height 1. Okay, let me not call it height 1, let me call it height c. So I don't want to just use pi r squared h, because the volume of the cone also has a h and c, but it's not the same because they have different dimensions. Minus 1/3 pi r of, then I have cylinder and cone. Okay, cylinder squared times the height of the cylinder. Then this is divided by the volume of the sphere. This is 4/3 pi times the radius of the cylinder cubed. So this is the formula, and you now just have to substitute and work out. So we have 0.95 times pi. The radius here is 8. The height is radius squared. The height is 20. We have 1/3 pi. The radius here is 3. The height is 8. And this is divided by 4/3 times pi. The radius here is 0.75 cubed. Okay, so this you just do on your calculator. So we get 2,121.2444 and so on. So the question is, how many of these spheres can you make? And the answer is 2121 spheres can be made. So you have to look at how many whole spheres. We don't want to make a part of a sphere. We just want to count how many full spheres can we make. Okay. Differentiate using the first principle. This one's simple, straightforward. You just substitute into the formula. This is equal to the limit as h approaches 0 of f of x plus h minus f of x over h. So this is the limit as h approaches 0. So where I have x, I replace that with x plus h minus 1 over x over h. This is the limit as h goes to 0. Adding these two fractions, we have x minus x plus h over x times x plus h. This is divided by h. So this is the limit as h goes to 0 of x minus h over x times h times x plus h. So these two will cancel. So I have the limit as h goes to 0 minus h over h x plus h. So these two will cancel. The limit as h goes to 0 minus 1 over x times x plus h. And now when I substitute, I no longer write the limit. So this is minus 1 over x plus 0. This is minus 1 over x squared. Okay, so that is how you do it. Straight piece of wire, 40 centimeters long. So you have a piece of wire like this. It's cut into two pieces. So you cut it there. And one piece is bent into a circle. And then the other piece is bent into a square. So this is what you have. How should the wire be cut so that the total area of both circle and square is optimized? And what will be the optimum area? Okay. So optimization, that's talking about minimizing or maximizing. And whenever we're doing these maximization, minimization, you always have to differentiate, equate to 0, and so on. Okay, so what we know is that this distance here is 40. Now, this 40 is used to make the circle and the square. So that means the perimeters of the circle and the perimeter of the square must add up to 40. So the perimeter of the circle is the circumference. So here we know that C is equal to 2 pi r. And here our perimeter is, you can call this side x. So this is 4x. Okay, so our formula that connects the radius and the side is 2 pi r plus 4x is equal to 40. You can divide everything by 2, so pi times r plus 2x, this is equal to 20. So this is the first equation. Now we are told that we want to optimize the total area. So we need the area of the circle plus the area of the square, and this must be optimized. So the area of the circle, this is pi r squared. The area of the square, this is x squared. Now you can see what we want to optimize is in terms of two variables, and we don't want that. So we want to write one in terms of the other. So we go back to this equation, and we can make x the subject of the formula. So we have 2x is equal to 20 minus pi r, and x is equal to 10 minus a half pi r. Then we'll come back and substitute here. We have pi r squared plus 10 minus a half pi r squared. So this is pi r squared. When we square this, write them next to each other. There's 100 minus 5 pi r minus 5 pi r plus quarter pi squared r squared. Okay, so collecting the terms with r squared, we have squared pi plus a quarter pi squared, then minus 10 pi r plus 100. Okay, so this is our formula for the area. Then we differentiate, we find dA, dr. Differentiate, the 2 comes down, so we have 2r pi plus 1 over 4 pi squared minus 10 pi, and then the derivative of 100 is 0. So we know that at the optimum area, dA dr is equal to 0. So we say 2r pi plus pi squared over 4 minus 10 pi. This is 0. So this means that 2r pi plus pi squared over 4 equal to 10 pi. So r, this is equal to 10 pi over 2 pi plus pi squared over 4. Okay, so it says we must leave our answer in terms of pi. So this was the 1, this was 5. So I have 5 pi, and this I will be dividing by 4 pi plus pi squared over 4. This is 5 pi minus 4 over 4 plus pi squared. So this is 20 pi over 4 pi plus pi squared. So that is our radius. And then we can work out the second derivative and then test to see, does this in fact give us the minimum? So D to A optimum, because it doesn't say whether it's a minimum or maximum. Okay, so differentiating this, we have 2 pi plus 1 over 4 pi squared. The derivative of this one is 0. And then d squared. This is positive. It doesn't matter what r is. Therefore, we have minimum area. So optimizing this means finding the minimum area. Okay, so now we find the side x. So x is equal to 10 minus half pi r. Okay, so this is 10 minus a half pi, and then our formula for the radius, 20 pi over 4 pi plus pi squared. This is 10 minus the half and the 20 will cancel, so you have 10 pi squared over 4 pi plus pi squared. So here I should have cancelled, factor out the pi. So this is 20 over 4 plus pi. That's in the simplest form. So here I will have 10 minus 10 pi over 4 plus pi. Okay, so leaving it as a single fraction, 10 so this is 40, 10 pi minus that, so this is just 40 over pi plus 4. Okay, so we have our radius is 20 over pi plus 4, even though it doesn't matter if you write 4 plus pi. And then the side of the square must be 40 over pi plus 4. Okay, then the question said find the optimum area. So our area, we said this is the area of the circle. This is pi r squared, and then the area of the square is x squared. So this you do on the calculator. So when you work it out on the calculator, you have 56.00991. It continues, and we have to leave it to 3 decimal places. So we get 56.010. So it's very important. Answer the questions the way they are stated. So if it says leave it to 3 decimal places, you must leave it to 3 decimal places. You will not get all the marks if you don't do that. Particle starts from rest, so that means the initial velocity is 0 at the point x is equal to 10 and moves along the x-axis with the acceleration equals to 12 t. Find the resulting function. Find the resulting displacement function x. Okay, so that's the displacement. So basically we are asked to find the displacement. So we know if we have the acceleration, the velocity, this is the integral of the acceleration with respect to t. So this is the integral of 12t dt. So this is 12t squared over 2 plus c, and this is 6t squared plus c. So we have to figure out what is c, and that is what I mentioned. It starts from rest. So when t is equal to 0, the initial velocity is equal to 0. So we substitute t 0 and v is 0, and then work out c. So v0 means 6 times 0 squared is equal to c. This means that c is equal to 0. So our velocity, this is equal to 6t squared. Okay, then the acceleration now, so we're not saying s, we're going to call it x because it's a function, that's what we're told to call it. This is the integral of the velocity with respect to time. So the integral of v dt, this is the integral of 6t squared dt, which is 6t to the power 3 over 3, and then we add k. So I just want to use a different letter, but using c here doesn't change anything. Okay, so we have our formula that x is equal to 2t cubed plus k. Now we have to try and figure out what is k. So we are told it starts from rest at a point x is equal to 10. So this is the initial displacement. So when time is equal to 0, x is equal to 10. So we then substitute and then work out the value of k. So we have 10 is equal to 2 times 0 to the power of 3 plus k. This means that k is equal to 10. So our function x of t becomes 2t cubed plus 10. Okay, so that is what we have. Find the area enclosed between the curves y is equal to 2x squared plus 3 and y is equal to 10x minus x squared. So these are two parabolas, and the only way the area can be enclosed between the two is we have one parabola that opens upwards and then another one that opens downwards. So that is the area between them. So what we need to do is figure out what are these points of intersection. Now this parabola here, because the coefficient of x squared is positive, this opens upwards and then this one opens downwards. So this is 10x minus x squared, and this is 2x squared plus 3. So our area is going to be the integral from this point here. I'll call it x1. This one I call it x2, from x1 to x2. And then we say the parabola that's on top, so it's 10x minus x squared minus the one that is below, 2x squared plus 3 dx. So this is what we will have to integrate. You just need to work out what are x and y. So we solve these two simultaneously. So we say 10x minus x squared is equal to 2x squared plus 3. So we have, this one goes downside, minus 3x squared plus 10x minus 3 is 0. Divide everything by -1. So we have 3x squared plus 10x. Okay, so we then solve this quadratic equation of the two numbers. When you multiply them, the answer is 9. When you add them, the answer is minus 10. Okay, so this is what you get when you factorize it. Then this means x minus 3 is 0, so x is 3. And 3x minus 1 is 0. This means x is 1 over 3. So now we integrate from the smaller one, so it's 1 over 3 to 3. Then we have 10x minus x squared. Then this is minus 2x squared minus 3 dx. Integral 1 over 3 to 3. Then we have minus 3x squared plus 10x minus 3 dx. This is minus 3x cubed over 3 plus 10x squared over 2 minus 3x. 1 over 3 to 3. Okay, this is just simplifying before I substitute. Minus x cubed plus 5x squared minus 3x. 3 to 3. Okay, now we substitute. We're going to start here at the space. So we have minus 3 cubed plus 5 times 3 squared minus 3 times 3 minus 3 cubed plus 5 times 1 3 minus 3 times Okay, so this you do on your calculator. Okay, so you should get 226 over 27, which is 8.370 it's squared. Okay, so leave your answer to the decimal places.